too nice. That is on your formula sheet. The interquartile range tells me, what is range? We learned that last time. Large minus small, max minus min. The interquartile range is telling me the range of my box. What is the high and low of my box? So it's Q3 minus Q1. So what two numbers would I subtract to get my interquartile range? So my interquartile range is going to be 60 minus 35 or 25. So it's not that bad once you kind of understand what you're doing. My interquartile range is the distance of my box, Q3 minus Q1, and that formula is given to you on your formula sheet. We good so far? We're going to do another one of these, I promise. All right, now we're going to talk about, write it out, lower fences and upper fence. Those are on your formula sheet too. Okay, your lower fence and your upper fence is used to help find outliers. Remember, outliers, if I say, y'all, everybody in this class made pretty good and then there was one person who really sucked on this test, or there was one person who really made really good, I want to know, is it an outlier? How bad is too bad? How good is too good for it to be an outlier, for it to be way away from the rest? This formula helps us determine how far out is an outlier. Bless you. So we're going to do Q1 minus 1.5 times the box and Q3 plus 1.5 times the box. Now, I'm going to scroll up and I'm going to show you your data again. Now, do you see our outliers are either going to be on this end or this end? Most of my grades, 20s through 70s, and then you have a 7. I need to know, is 7 an outlier? Is it too far away from my data? Is 99 an outlier? Is it too far away from my data? This upper fence and lower fence is going to help me determine that. What we're going to do is we're going to take Q1 and we're subtracting, because we're going this way, we're doing lower fences. Q1 minus 1.5 boxes. So if it's more than 1.5 boxes below my first quartile, then it's an outlier. And then I'm going to take Q3, and if it's more than 1.5 boxes this way, then it's an outlier. So that's kind of like where I draw my line. If you're outside that line, you're not my friend, you're an outlier. So, what was our Q1? Our Q1 was 35 minus 1.5 times the interquartile range, which was my box. So I go to my calculator and I say start at Q1 and subtract or go to the left 1.5 times the size of my box. So that means any data point that is below negative 2.5 is an outlier. So, do I have any data point that is below negative 2.5? That is my lower fence. No. So I don't have any outliers on the negative side. Now I'm going to go the other way. I'm going to do my upper fence. I'm going to draw a line to say, do I have any outliers on the upper side? What is my Q3? 60. So 60 plus 1.5 times, what was the size of my box? 25. So I go to my calculator and I'm going to do 60 plus 1.5 times 25. So 97.5 is my upper fence. Oops. So 97.5 is my upper fence. So do I have any outliers on the upper end? Yes. So from my lower fence and my upper fence, it's like I'm drawing boundaries. Negative 2.5 or below. So if I have any numbers that are negative 2.5 or below, those would be considered outliers on this end. Any number that's 97.5 or higher would be outliers on this end. So this is my only outlier. 99 is my only outlier. That is my only outlier. Cool? Now, let me show you the same problem if we go to our calculator. If we do stat edit, let's go ahead and clear out both of them. Stat edit, clear out both. I only have one set of data. Type in all data, even though we know that that last one is an outlier, you should have 11 pieces of data. So stat edit, type in all pieces of data. There's 11 pieces of data. Until y'all get it in and I'll scroll down. 11 pieces of data. I'm going to scroll down and show you how our calculator will do a good bit of this for us, but you always need to have a backup. So I did stat, edit, okay. Now, we only have one set of data, so we don't have to worry about the L1, L2. So let's just do stat calc, one var stats. Now, if you still have L2 left over from last time, you need to clear that out. You only need L1 because we're only dealing with one set of data. There's page 1. I'm going to scroll down. There's page 2. Okay? Now, we have learned this chapter that this is my mean. We have learned that this is what? The second error I just drew. This is our sample standard deviation. What is this one? Population standard deviation. This just tells me that I put in 11 pieces of data. That's all that one says. Now, look right here. There's our 5-number summary. There's our minimum, there's our Q1, there's our medium, there's our Q3, there's our maximum. So the bottom of the second page is going to give us that 5-number summary. But I wanted you to understand what that 5-number summary means. Okay? So if you have to draw a box and whisker, you can easily look at that and say, from that, when I draw my box and whisker, I'm going to have a 7, a 35, a 50, a 60, and a 99. That's going to be my box and whisker. How would I get my variance? If I ask you to find the variance, what would I do? I would square either that one or I would square that one according to which one I'm asking. How would I get the range? Max minus min. Now, what if I wanted you to use the calculator to draw a box and whisker?
Y.
Second Y. We would go to second Y equals. Second Y equals. We would hit enter. Now, I don't have the box and whisker, and the box and whisker I like to use, y'all, is this first one. There's two box and whiskers. I like to use that one on the left. So if you'll go down and then go over until you get to that first box and whisker and then hit enter. That's the one that I like to use. And then what are we going to do after we choose it? Zoom 9. Look at me.
Oh, you gotta change it to L.
Oh, let me see, what did I do? Second Zoom 9. I think I had, oh, stop yelling at me. Second Zoom 9, I think I had it set for, oh, I had L2, and it's yelling at me because it's saying there's no data in L2 for me to look at it. So I changed it to L1. Pull that over and cover it up. And now I'm going to Zoom 9 it. Or not. Is it yelling at me again? Did y'all Zoom 9? Alright, why is it in the graph? Hold on, it's yelling at me as something now. Second. Do what?
It's still saying L2.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Enter. Zoom. 9. Why is it not liking me? Step 1. Oh. There we go. Now, look what this shows me. What should that be at?
7.
7. This is going to be at my other numbers. What do you think that is?
The outlier?
The outlier. It shows me my outlier on here. Now, another thing that this also shows me about the data is that when you're showing your graph, and let me just draw like a baby graph on here. Each part of your box and whisker, this represents 25%, your second quarter represents 25%, your third quarter represents 25%, and your fourth quarter represents 25%. It's like a football game. Every quarter of the football game is like a quarter of a dollar. It represents 25%. So 25% of your data falls here. 25% of your data falls here. 25% of your data falls here. And 25% of your data falls there. Okay? That makes 100% of your data. We cool? All right. Another thing that I do want to make sure that you understand, and it's this simple, is percentiles. And we're going to do another question in just a minute. If I tell you, and I'm going to tell you, my baby daddy was not good at math at all. He actually started dating me his senior year of college so he could get out of math because he just went to college to play sports. So, when we had our child, and does anybody in here have children? Okay. So when you go to take your child to the doctor the very first time, they measure their head and their weight and their height, and they tell you what percentile they're in. Or when you are graduating to high school, they'll tell you what percentile you're in, or you get your SATs, and they'll tell you what percentile you're in, okay? So we've all heard of percentiles before. Well, when my child got measured, she's 13 now, but when she got measured for her head, her height, her weight, they told me that her head was in the 54th percentile. My ex-husband freaks out. My baby is not perfect. He wanted it to be 100%. So I had to sit there with my baby in my arms and explain that if Madison's head was in the 100th percentile, so So sometimes, y'all, just like with the swimming, you want to be on the low end. If it was your grades in school, we would want our percentile to be super high. You know, we want to be the smartest. So if you're in the 99th percentile for your grades, that means you're smarter than 99% of the population your age. But this is saying that my child's head is bigger than 54% of the population. I don't want her to be 100%. Okay? Now, when we got to her height, what does that tell you about my child?
She's tall.
My ex-husband is 6'4". I already look up to my child. She has outgrown my shoes in like 4th grade. So this tells you that Madison is super tall. So she is 95% taller than, 95% taller than the girls her age. So there's 5% people that are taller than her, okay? And then for her weight, I want to say she was like, something like that. She was in the 48th percentile. So she was about average. So in some cases, you want the percentile not to be 100. So if I say that you were in the 75th percentile on the SAT, what percent scored above you? 25. What percent scored below you? 75. So you need to understand what percentile means as far as who's below you and who's above you. Make sense? All right, next problem. Let me cover up. We have looked at the hemoglobin in cats, and we've selected 20 cats. We want to compute the z-score corresponding to the hemoglobin of Blackie. Poor old Blackie got his hemoglobin, and he got a 7.8. We want to determine the quartiles, quartile 1, quartile 2, quartile 3, quartile 4. We want to compute and interpret the interquartile range and determine the upper and lower fences and determine if there's any outliers. So first, z-score means data minus mean over standard deviation. Do we know the mean? Do we know the standard deviation? So how are we going to get the mean and the standard deviation? Put up your calculator and run 1-bar stats. So before you can get the z-score, you've got to get the mean and the standard deviation. This one's a good one, y'all. Ugh! Today is the last day for sign-in sheets. I'll pass it around in just a second when I find it. Here it is. After today, I'll just be call and roll. one's a good review for the test. Y'all ready for me? How are we feeling about it? All right, so in order to do the z-score, and I'm going to have it pretty underneath, but in order to do the z-score, we have to do data minus mean over standard deviation. Well, the problem is, we know the data. The data is 7.8. We don't know the mean and the standard deviation. So in order to get the mean and the standard deviation, we've got to run one of our stats. Okay? So I'm going to go to my calculator. I'm going to stat edit, go to the top. Doesn't matter if I go across or up and down.
It just did 7 for the one that's supposed to be 7.7.
Thank you. Keep an eye on me.
Yeah, I did 0.7.
7, 8, 8, 7, 8, 9.
There's two 9.6s.
Help me, Lord Jesus. Okay. Where was it? Up, down.
Right there. 9 point.
There's two
No,
of
there's
them.
supposed to be 2 and you put 1.
Okay. Let me add it. 10, 3. Okay, that doesn't need there, so I'm gonna put a 9.6 there.
And then 10.6.
And do 10, 6, and now I can roll. I missed a something, didn't I? No. 11.2, 11.7, 13.4. Am I good?
Yeah.
Okay, so Once I get my data in, there's 20, so I should be on line number 21, and I'm gonna do stat count, 1 bar stats. I have L1 in there, and I need my mean, which is 10.08, and I need my standard deviation. Is this going to be a sample standard deviation, or is this going to be a population standard deviation? Sample. So I'm going to use 1 point, and I'm going to pull this over. Right there. So I'm going to use this, and I'm going to use this. So it's going to be 7.8 minus my mean, which is 10.08, over 1.8858 or 886. So that is going to give me my z-score of, what did y'all get?
I did everything wrong. I don't know, I did variance, so I squared my sample. What is variance? Now I don't know what variance is.
You're only going to do variance when they say find variance.
Okay,
Yeah. You're only going to do variance when it says determine the variance.
okay,
But for z-score, it's going to be data minus mean over standard deviation.
okay.
And standard deviation is just going to be that SX or that sigma X, according to whether it's population or sample. And the reason this one was a sample is because up in here it says we randomly selected 20 cats. We just took a sample of 20 cats.
Do you have to carry, like, do the decimal point? Like, I only did 1.8 as my standard deviation. Will it, like, off your z-score if you?
I usually go 2 or 3 places after. On your test is all multiple choice.
Okay, so it won't really be a question. You'll know if it's, because I got negative 1.27, but I think it's because
Because you rounded.
Yeah.
Yeah. I would go like 3 or 4 places just to make sure. So this is kind of that written out. My data was a 7.8, that was the blackie. My mean and my standard deviation I got by doing the 1 bar stats. And then I just took it several places out and I did data minus mean over standard deviation and I got negative 1.21. Now tell me how blackie relates to all the other cats. Is he better than the cats or worse than the cats? Is he above the cats or below the cats?
Well, I don't know.
Who?
I don't know if you want more or less hemoglobin, but he's below.
He's below the cats. He's 1.2 jumps below the cats. Okay? So, if I draw a little picture, he's a jump and a little bit below the cat. So this is where Blackie's standing compared to everybody else. Got a visual? Now, what did Part B say? Part B said, determine the quartiles. Where am I going to go to get the quartiles? 1 bar stats, and I'm already there. So if I scroll down, this is where I'm going to get the quartiles. And I have it right there. I got it from the second page of 1 bar stats. Okay. Then question C says, compute and interpret the interquartile range. So off your formula sheet, it said that the interquartile range was Q3 minus Q1. So Q3 minus Q1 is going to give us our interquartile range.